Hello, my precious friends. I really hope that you are doing great. Welcome to our today's class. It is our fourth lesson on the sixth topic of Form 4, which is called mains electricity. As usual, let me commence by giving the quote of the day, which states that when a light bulb blows out, you do not buy a new house. Instead, you fix the light bulb. We shall discuss that quote at the end of our class today. So today we are looking at the cooker circuit, whereby you are saying that the cooker circuit consists of the cooker and the water heater circuits. So these circuits are usually earthed. The reason is to reduce the possibility of electric shocks, and also their wires are usually relatively thicker. So the reason why their wires are relatively thicker is because these circuits they carry large amounts of current. So if a given wire is carrying a large amount of current, it simply means that the wire has to be thicker, so that thicker wires have larger cross-sectional area. That means they have more number of electrons per unit area responsible for electrical conductivity. Therefore, thicker wires usually have low electrical resistivity, as we saw in a given chapter in Form 3, which was called Current Electricity 2. You can just review it. It is a chapter that we covered in this particular channel. So we are saying that the circuits, that is the cooker circuit, or simply the heater circuits and also the cooker circuits, these circuits are earthed, and their wires are relatively thicker than those of the light circuits. Remember, we saw that light circuits usually carry small amounts of current of about 5 amperes. Therefore, they do not need thicker wires. Instead, they just need some thin wires because they are carrying small amounts of current. But for the cooker circuit, we have to use very thick wires to reduce because they carry a large amount of current. Therefore, the thicker wires would reduce the loss, or that is the loss of current on the way, or they simply reduce resistivity in that particular wire. Then we look at the ring main circuit. So the ring main circuit carries the sockets on the walls. So they use 3 wires. We have the live wire, which is usually either red, or in sometimes it can also be brown in color. They also use the neutral wire, which is usually either black or blue in color. Then we also have the earth wire, which is usually green, or sometimes it is usually green with yellow strips in color. So you can see this is what we are calling our ring main circuit. So of course, this is the main switch, which has some double walls. So we have the neutral double wall of this particular main switch, which will connect to the neutral wire here. Then of course the upper pole is what we call the live wire, which when closed, this particular wire will connect with this other wire here. So you can see the live wire. Through the live wire, we are connecting these particular fuses. So the 5 ampere fuse, these are fuse for the light, that is for the lighting circuit, because it needs small amounts of current. Then of course the other circuits are for this one, the 30 ampere. This one is for the cooker circuit, which is needing a large amount of current. That is why it is using wires which are relatively thicker. Then we have what we call the ring main circuit, which we are having this particular fuse that is connecting to the ring main circuit. So the ring main circuit consists of the sockets that are within the house. So this is our first socket, this is another socket, this is the other socket. So maybe this could be a socket, maybe a socket in the sitting room. We can also have maybe another socket in the kitchen room. Then we can also have maybe another socket that is in the bedroom. So you notice that for this particular socket, each socket has 3 wires. That is the live wire, we have the neutral wire, and of course the earth wire. So it is important to connect the earthing wire so as to reduce any possibility of electric shocks. So you can see the live wire, which is usually in red in color. It is coming to connect to this particular port. Also the red wire is also coming to connect to the this particular port of this particular socket. Similarly, the red wire is also connecting to, or the live wire is also connecting to this particular port of that is the socket. Then if you also follow, we also have the neutral wire. We have this pole which is connecting to the neutral wire. Similarly, the neutral wire is this one, which is black in color. You can see also the neutral wire is connecting to this particular socket. The same neutral wire is also connecting to this socket, and it also connecting to this other socket. Then lastly, we have the earth wire or the earth terminal. So this earth wire, which is green in color, it is also connecting to our first socket. Similarly, it is also connecting to the second socket, and lastly it is also connecting to our third socket. So the ring main circuit, they consist of 3 wires: the live, the neutral, and of course the that is what we call the earthing wire. So you can see clearly how those wires are being connected. So this is simply a typical connection within a room. So this is how we connect the ring main circuit. So let's see the reason why we need a ring in that particular circuit. So the loop arrangement of the cables, it enables double path for the current. So the loop arrangement also effectively increases the thickness of the wires used. So this reduces the risk of overloading the circuit when several sockets are in use. So you can be asked to give a reason or an advantage of the loop arrangement of the cables that is in the ring main circuit. So the loop arrangement of the cables, so the loop are these simply complete loops. You can see this is a complete loop for the neutral wire. We also have a complete loop for the that is earthing wire. Similarly, we are also having this circular, that is a rectangular complete loop of this particular live wire. So the importance of the loop. So the loop arrangement of the cables enables the double path of the current. So that is the first reason. The other reason is that the loop arrangement also, it effectively increases the thickness of the wire. Remember, when the wire is thick, simply resistance of current through that particular wire will also be relatively low. So less current will be lost on the way. So this reduces the risk of overloading that particular circuit when several sockets are in use. So remember, when we are having several sockets being connected to this particular ring main circuit, because of the arrangement of these wires, there will not be overloading of those particular circuits. Then we are saying that appliances using the ring main circuit are usually provided with a third wire. A third wire casing connected to the casing. So appliances using the ring main circuit are provided with a third wire connected to the casing. So from the power socket, this third wire links with the earth terminal at the consumer unit through. So that is it. So next, we look at the 3-pin plug and its socket. So this is what we are calling a 3-pin plug. Remember, when you open the socket in your house, this is what you are going to find inside. You are going to find a wire which is usually red in color. That is what we are calling the live wire. Then of course, on the live wire, we usually connect the fuse. So remember, in any electrical connection, so this chapter actually gives you a basis for those of you who are interested in electrical engineering. So the first thing you need to note is that the fuse must always be connected to the live wire and not to any other wire. Then we have this other long wire which is usually green in color. That is what we are calling the earth terminal, or simply the earth pin. Then we have the other black wire which usually connects to the neutral wire, or what we call the neutral pin. So this is our neutral pin, this is the earth pin, then this is the live pin whereby we connect the fuse. So the fuse must always be connected to the live pin or to the live wire. Then this is what we are calling the socket for the 3-pin plug. So this is where you connect the charger of your smartphone or the charger of your laptop. So this is what we are calling the hole for the earth pin. Then this is the hole for the live pin. Then this is the hole for the neutral pin. Even when just check on the charger of your smartphone or the charger of your laptop, you realize that there is an L which has been labeled on the right end of that particular charger. Just look at it. Then we have an N labeled. So N stands for neutral hole, then L stands for the live hole. Then there is also an E which has been labeled on that particular charger of your smartphone or the laptop. So just check it. That is the part which connects in these particular holes. So the E stands for the earth pin, or the hole for the earth pin. So the 3-pin plug has 3 pins. So the first one is what we call the live wire or the live pin, which is usually the live wire is usually red in color. It connects to the live pin. Then we have the neutral pin. So this is where we connect the black wire, which is usually the neutral wire. Then we have the earth pin, where we connect the green color, that is the green wire, which is usually the earth pin or the earth wire. then the earth pin is usually longer than the live and the neutral pins. So since it is the first to enter and open the blinder, which covers the live and the neutral holes of the socket. So just look at the charger of your smartphone, or the charger maybe of your television, or the charger of even your laptop. You realize that there is a third pin which is usually longer, and it is usually on the other side as compared to the first two pins. So the last pin is always longer. Just compare the length of the first two pins and this other third pin. You realize that the third pin is usually longer. So the reason for that is that when you connect that particular charger of your smartphone in that particular socket, this one will be the first one to enter that particular hole. So what is the purpose of it first entering the hole? So it is the first to enter and open. The reason is for it to open the blinder, which covers the live and the neutral holes of the socket. So when the blinder is opened, now the neutral and the live wire can enter or can connect in that particular socket. So it is important that you realize that the earth pin is usually longer because it is the first one to enter and open the blinder, which covers the live and the neutral holes of the socket. Remember, in most cases, the blinders are usually white in color. Just check when you connect the that particular charger in this particular socket, you realize that once the first pin enters, you will see some white materials actually escaping or opening holes for the neutral and the live wire. So that white material, that is what we are calling the blinder. Remember, if you have a charger that has two pins, there are chargers with two pins, the neutral and the live alone. For such chargers, you cannot connect them in this particular socket for the 3-pin plug. So the only circumstance when you can connect them is when you first of all open this particular earth pin. You can use maybe a plastic material, for example, the biro pen, so you can use it. So you have to open that particular blinder first of all before you connect the other two holes. Actually, I'm sure this is something you have experienced in real life. When you have a 2-pin charger, you have to come with a third material to help you open that particular earthing terminal. So the reason is because it is not having the earth pin, whose role is to enter and open the blinder, which covers the live and the neutral holes of the socket. Then also don't make a mistake of opening this particular blinder or connecting the earth terminal with that is a good conductor of heat, because you are going to experience an electric shock. So you have to use a poor conductor of electricity. For example, you can use plastic material or rubber materials to avoid dangers of electric shocks. So remember, the earthing terminal helps to reduce those possibilities of electrical shocks. Then when you connect to excess current, what will happen is that the fuse is going to blow out, hence protecting your electrical appliances. Even if when you check the chargers, especially those of laptops, you will see it has been written on it fused. So the charger of those particular laptops, they usually also have a fuse inside, so that when excess current is flowing through, that fuse of the charger is going to blow out, hence safeguarding your charger against electrical shocks. So in most cases, when you find the chargers of laptops or maybe the charger of televisions being not effective, so the main reason is usually that the fuse has blown out. So what you do, you just purchase another fuse, then fix it there, then you'll see your charger will start functioning normally. So these are very important points that examiners like. So you need to know the reason for the earth pin, why the earth pin is longer than the live and the neutral wire. So it is the first to enter and open the blinder, which covers the live and the neutral holes of the socket. Then the fuse is fitted to the live wire. Strictly, the fuse must be fitted on the live wire and not the other wires. So the reason is to protect appliances from excess current, because remember, when you disconnect the live wires, actually the neutral and the earthing wires do not have huge amounts of current. So once you connect the live wire, then it means you are free from electrical shocks. So the fuse is fitted to the live wire. The reason is to protect the appliances from excess current. Now when the current flows, when the current flowing exceeds the required value, the fuse wire melts and breaks the circuit, hence protecting the electrical appliances. If you look at the charge of your laptop, or maybe the smartphone, you will see the amount of current that is required to go through there. So if excess current is coming which exceeds the fuse rating in that particular laptop charger, then actually that fuse is going to blow out, hence it will protect your laptop or maybe your television against electrical shocks or getting destroyed. Then the fuse value should always be slightly above the current value of the appliance used. Remember, we looked at these when we were tackling a given topic in Form 3, which was called heating effect of an electric current. So we said that, for example, a 5 ampere fuse is suitable for an appliance operating on a 4 ampere current. So the fuse value should always be slightly above the current flowing through the appliance being used. Otherwise, if you do the opposite, it means that particular appliance will not work, because once you connect it to the fuse, to the charger, the fuse is going to blow out even when excess current is not flowing through that particular fuse. Lastly, we look at an example which reads that a house has a lighting circuit operated from 240 volt mains. Then 10 bulbs rated at 100 watt and 240 volts are switched on at the same time. What is the most suitable fuse for this particular circuit? So the first thing, we are going to find the current flowing through all these particular bulbs. And remember, because we are given the power as 100 watt and the voltage as 240 volts, we are going to use the relation power is equals to VI so that we find the current. Remember these formulas, we derived them under given a topic in Form 3, which was called heating effect of an electric current. You can just review. It is a chapter that we covered in this particular channel under Form 3 work. So if I make current subject of the formula, current will be equal to power divided by the voltage. So because we are dealing with 10 bulbs and each bulb has a power of 100 watt, so it means the total power will be 10 multiplied by the power of one of the bulbs. So 10 times 100, of course, you'll get 1000 watt, divided by the voltage is simply 240 volts. So 1000 divided by 240, you are going to get a current of 4.167 amperes. Then we said that the suitable fuse for this particular circuit is 5 ampere fuse. So we said that the fuse rating should be slightly higher than the amount of current flowing through, so that when excess current flows through, actually it is going to approach 5 ampere so that the fuse will blow out. Otherwise, if the fuse rating is lower than the current flowing through, then in such a case, that particular circuit is not going to work, because each time you put on, the fuse is going to blow out. Because remember, the fuse wire usually melts whenever excess current is flowing through it. So the suitable fuse for this particular circuit is a 5 ampere fuse, because 5 ampere fuse is slightly higher than a current of 4.167 amperes. Then lastly, I have an exercise here that I recommend you should try at your own free time to get the understanding of the concept that you have just learned. Of course, if you have any challenges in handling any of the questions, feel free to drop a comment specifying the question that you need help in. And as usual, I'm always here to try and help where possible. So we've come to the end of our class today, but we need to discuss the quote of the day. The quote of the day stated that when a light bulb blows out, you do not buy a new house. Instead, you fix the light bulb. So the quote is simply encouraging us to own our mistakes, and that instead we should not run away from our mistakes. Instead, we should own them and try to find solutions to them. So that is the only way that you can learn and grow. So don't run away from the problem. For example, you don't run away from your house because the bulb has blown out. You simply purchase or fix that particular bulb, then you continue living in the house. Similarly, in life, you also have to approach it that way. When you find an obstacle, find a way of solving that particular problem instead of running away from it. And lastly, remember that we do not solve problems by postponing them to a later date. Because when you postpone a problem, you are simply accumulating those problems. So it is better you handle it when immediately you encounter that particular problem, so that you are able to grow and focus on other things. Thank you very much for accompanying me until the end of this particular lesson. I do not take it for granted. In case you are new to the channel, kindly hit the subscription button and also turn on the notification bell so that whenever I upload a new video, you'll get notified. Until next time, this is Kind Tuition Academy. Thank you very much.